All right, so for the next lesson, we're splitting it into two parts. We're going to take a look at what's called related rates. So we're going to combine what we've done for the last three lessons in terms of the application, especially 3.3, and we're going to tie it into using formulas from geometry, formulas from being able to relate or problem solve, and we're still going to be applying those same concepts that are going to force us to do the implicit differentiation. So like it says, sometimes we're given the rate that one quantity changes with respect to time and are then asked to find the rate that another quantity changes with respect to time, which means that what we're really looking for is the derivative with respect for time. So velocity, we already know, is the change in position over the change in time. Acceleration is the change in velocity over the change in time. And the rate at which a population can grow is going to be the change in population in relation to time. Related rates are rates that are affected by some factor and they change together. And that is one of the key aspects. They both have to be affected when this change happens. Like if something's changing over time, then both those related values will change in relation to time as well. So we can talk about interest in your bank account that varies with the balance of your account. We can talk about the area of a rectangle changes as the length of one of the sides changes. And like we said, when working with related rates, we'll often be using implicit differentiation. So because I'm solving for the change in y over time, then that means that I'm taking the change in y over the change in x, or the differentiation of y in terms of x, multiplied by the differentiation of x in terms of time. Now, here are some key things you need to know in order to fully show your work, to fully get marks. 1, you need to define your variables and draw a diagram if you can. Now, it doesn't have to be overly complex, but the more complex the question gets, the more the diagram is going to be necessary. 2, you need to write down the rates that you're given and the rate that you need to find. 3, we're going to find an equation that relates to your variables. Now, for today's lesson, we're primarily looking at some of those three-dimensional objects or two-dimensional shapes, because it's all related around geometry, that we covered in grade 10. The next one is, if it is all possible, and there's a key for doing this, we're going to eliminate variables that we don't need to use. In fact, in some cases, it's going to be essential because we don't know what the relation of that variable is over time, which means we have to be able to eliminate that variable in order to solve a different relation. We're going to differentiate both sides of the equation with respect to time. And then we are going to evaluate the required rate by substitution into your related rate equation. Now, we should also include a statement answer with correct units. Because we're problem solving, we should always state a final answer that relates what is going on and in terms of the units of whatever it is we're solving for. All right, so let's take a look at example 1 here. So example 1 says differentiate y is equal to 20x to the negative 1 with respect to time. That with respect to time means that we're going to be doing implicit differentiation. Because remember, we are not doing what y is in terms of x, we're doing what y is in terms of time. So if I have y is equal to 20 x to the negative 1, and I'm going to do y in terms of time, then that means that I also have to differentiate x in terms of time. And this is where we're using that implicit differentiation. So I'm going to differentiate what I have here. I'm going to say that I have negative 20x to the negative 2. But I also have to multiply that by the differentiation of x over time. What that actually means is I'm going to have negative 20 over x squared multiplied by dx over dt, and that's going to give me my dy over dx. So don't forget, because we're not doing the differentiation of y in terms of x, we're doing y in terms of t, we have to use that implicit differentiation. For example 2, it says, given x squared plus y squared is equal to z squared, find the differentiation of z in terms of time. Well, when I do this, I'm going to differentiate both sides of the equation, and remember that I need to differentiate each of these variables in terms of time. So when I differentiate x squared, it's not just 2x, it's going to be 2x times dx over dt. Same thing with y, because I'm doing it in terms of time. It's going to be 2y times dy over dt. And on the right-hand side, that z squared is going to be 2z and dz over dt. At this point, I'm going to simplify. Well, I can start by dividing every single term by 2 and canceling out the 2's. And because I'm trying to get that differentiation of z over time, I'm going to divide both sides of the equation by z. Which means that dz over dt is going to equal x times the differentiation of x over time plus y times dy over dt, all divided by z. Unlike with the first two examples, in this case, it's asking for the differentiation of x over time, and it tells me the value of y. So when it says if x squared plus y squared plus 25, x squared plus y squared is equal to 25, and dy over dt is equal to 4, then find the differentiation of x over time when y is equal to 3. Well, I'm going to take my original formula, I'm going to take my y is equal to 3, and I'm going to use that to solve for what x is. So if x squared plus y squared, or 3 squared, is equal to 25, then that means that x squared plus 9 is equal to 25, which means x squared is equal to 16, or x is equal to the positive or negative square root of 16, which is positive or negative 4. Now, what else do I know? I'm differentiating both sides in terms of t. So when I differentiate this equation, I'm going to get 2x times dx over dt, 2y times dy over dt, and that is going to equal the differentiation of the constant is just 0. We also know that x is equal to positive or negative 4. We know that y is equal to 3, and we know what dy over dt is. So I'm going to use this for my two possibilities. Because I have two possible values for x, I'm going to say that I can say when x is equal to 4 or when x is equal to negative 4. So in the first case, I'm going to say that 2 times 4 times dx over dt, which is what I'm trying to solve, plus 2 times y is 3, and dy over dt is 4, is equal to 0. Which means that 8 times dx over dt plus 24 is equal to 0. Eight times dx over dt is equal to negative 24. And in this case, dx over dt is equal to negative 3. When I use the negative 4 for x, I get a very similar answer. Because my equation is basically the same, except for I have negative 8 dx over dt plus 24 is equal to 0. And when I divide negative 24 by negative 8, dx over dt is equal to positive 3, which means that dx over dt is going to equal positive or negative 3.